All right, so this means you have your headphones in and your paper notes in front of you following along. Remember to put your name at the top because I will have the sub collecting this to look through it on Monday. So given the following, rewrite it as its inverse function. So remember that the inverse of a log is an exponential, and the inverse of an exponential is a log. So if we were to rewrite this as its inverse, you would take the base, so 2 to the power of 3 is equal to 8. That's making a true statement. Now, if this is an exponential and we need to turn it into a log, well, the base of my exponential is 10. The exponent is 3. And my answer is 1,000. So if we follow along on the proper steps, we have log base 10. So your script matters. It needs to be smaller. My answer, which is 1,000, equals my exponent. What I want you to try right now is how could I rewrite this log based on what we talked about in class? Log base 10 can also be written as, try writing it, and then you can check to see if you got it. You could have also written it like this because a base of 10 can be assumed if not given. All right, so pause the video, take a moment, and rewrite C and D as their inverse functions. All right, let's take a look. We have 4 to the 1/2 power is equal to 2. That's a true statement because to the 1/2 power means square root. All right, let's try D. So log base 1/9 as a subscript of 81 is equal to -2. Awesome, so just practicing rewriting what those inverses are. So now let's take a look. Determine the two integer values the expression below lies between. So what we would do here is we say, okay, we have to evaluate it. Let's set it equal to x. 3 to the what power is 30? Well, there's no really actually like whole number that is going to be 3 to a power equals 30. So what we're going to do and check is we're going to do our 3 to the powers of. So 3, let's list them out. Three to the power of 1 is just 3. 3 to the power of 2 is 9. Okay, 30 isn't between 3 or 9. 3 to the third is 27. Okay, 30 is not between 9 and 27, so not those. 3 to the fourth is equal to 81. So what we're going to say is if it's between these two values, log base 3 of 30 is going to be greater than 3, but less than 4. So that's how we would do that type of problem. If you have any questions, there will be similar to that. If you need more examples like that, just reach out to me and I will provide you with them. All right, let's write out our inverse functions. How do you undo addition? Subtraction. How do you do multiplication? Division. How do you undo, or what's the inverse of a quadratic? A square root. What's the inverse of a cubic? a cube root. And the new thing that we're learning is what's the inverse of an exponential? A logarithm. Now there's a special inverse that we talked about yesterday. What's the inverse of e to the x? That's ln, which is called a natural log. All right, so what I need you to do is let's take a look at these expressions below. Evaluate each expression. So I want you setting them equal to x. Rewrite them as an exponential. And solve. So what I want you doing with all of them right now is figuring out what they are equal to. So I want you to pause the video and try these. So pause the video, go through and try these problems to check to see if you have an understanding on them. I would say this should take you 5 minutes or a little more, so I'll give you that time. All right, I'm assuming at this point you've paused the video, so let's practice rewriting our logarithms as exponentials so we can solve. So we start by saying 7 to the what power is equal to 49. It's not 7 to the 7th power because that's going to be some really big number. It's going to be to the 2nd power, so x should equal 2. 7 squared is 49. Another way to think about that, if that confuses you, 7 to the x, if I change the base, well, 7 to the 2nd is 49, x equals 2. All right, in this situation, my base is 2. So 2 to what power is 1 over 16? Well, I know if I go from a whole number to a fraction that my exponent needs to be negative. So we know x is going to equal some number, some negative number. Now, 2 to what number is going to equal 16? 2 to the negative 4th. Again, another way to think about that is 2 to the x. Well, how do I rewrite 1 over 16 as a fraction? Or sorry, with a base of 2, 2 to the negative 4th. That's why x equals negative 4. Again, remember, you can pause the video at any point if you need to. On C, you might be thinking, Miss Maga, you forgot to put a base here, but we've had this conversation. If I don't have a base given, we can assume that it's a base of 10. So we can rewrite this as an exponential and say 10 to the power of what is 100? Well, 10 to the 2nd power is 100. Awesome. Again, taking a look, let's rewrite as an exponential. We have our base to the power of some unknown number is equal to 1. Anything to the what power is equal to 1. Anything to the 0 power equals 1. So if you ever have an argument here, if that number is 1, you automatically know 0. All right, for E, 64 to the power of what equals 8. Two ways to think about that. If I go from a bigger base to a smaller answer, we know we're going to be having some type of root or fraction in my answer. I know that 8 is the square root of 64, so you might just know that x is equal to 1/2 because that means square root. If that confuses you, you can do a change of base, so get a smaller base, so common base, so 8 to the second power is 64 equals 8 to the first power is 8. You could take your exponents and set them equal to each other when you have the same base. Divide by 2, and you still get x equals 1/2. Again, if you have any questions, putting a star down next to it so when I look through on Monday, I can see. All right, 2 ways to think about this one. So I'm going to write it out in 2 situations so you have that. You can either say, okay, I know that natural log of e is 1, so my answer will be 5. Or you can say that I know that the natural log has a base of e, that's just assumed. And if we set it equal to x, we say e to the x is equal to e to the 5th. In order to make this true, x needs to equal 5. All right, for G, 8 to the what power is equal to 1 over 64. I go from a whole number to a fraction, so you know it must be negative. Now 8 to what power is 64? To the second. So my answer will be x equals -2. All right, again, rewriting h as an exponential. 2 to the what power is equal to -8. A lot of people might say 2 to the -3rd. The issue is the answer is not 2 to the -3rd because that would be 1 over 8. I cannot raise a positive base to an exponent and get a negative number. So when this number is negative, it's actually not possible. All right, for J, we've talked through this one. The base of my exponential and the base of my log match, meaning my answer will be 8. Another way to think about this is if I simplify my exponent, 2 to the 3rd power is equal to 8. So this we can replace this with 3, which 2 to the 3rd is 8. All right, again, our simplifying. The square root of 7 to what power is 1? Anything to the 0 power is 1. Now we come to L and we say 9 to the what power is 27. So 9 to the 3rd power, no way, because 9 to the 2nd is 81. So if there's no distinct number, we're going to change our bases here. So we want them to have the same base, so we're going to make them have the base of 3. So 3 to the 2nd power is 9, and we can't forget that x. And 3 to the 3rd power is 27. Now we have equal bases, so we can set our exponents equal to each other, and you have 2x equals 3. I divide by 2, and I get x equals 3 over 2, which means that I would square root x and then raise that number to the 3rd power to get 27. All right, for M, you can either know right away when base and argument match, it's 1, or 8 to what power is 8? It will just be 1. Again, if you had any questions on any of those, please put a star so I can know that you have questions when I look over it on Monday. All right, again, Let's go through these. I'm going to have you pause the video. Try these if you haven't already. So pause the video, attempt these. All right, at this point, you should have had the opportunity. You pause the videos, taking a moment to try them, and now we'll go through and you can check to see if your answer is correct. I am not going to give you the answer to 2 of these because I want to check to see that you have an understanding on your own. So again, we have log base 1/2 of 32 equals what? So 1/2 to the what power is equal to 32? Well, right away, I know when I go from a fraction to a whole number, I will have a negative exponent. Then I ask myself, 2 to the what power is 32? Which would be 2 to the negative 5th power. For E, there's 2 ways to think about this. O. Our first one, we talked about how natural log of E is just 1, and I'm left with 12. Or you can say, I know that natural log has a base of E. So E to the X is equal to E to the 12th. Our exponents must match, therefore X equals 12. All right, for our next one again, change that. 25 to the what power is equal to 125. If I do 25 times 25, oh geez, that's not going to be 125. Again, here you have to do your change of base. What base can I pick that will work for both of them? My common base here is going to be 5. So 5 to the 2nd power is 25. 5 to the 3rd power is 125. I can't forget about that x that was already there and my equal sign. When I have bases that are equal, we can set the exponents equal to each other and solve. So we get 2x equals 3, divide by 2, and you get x equals 3 over 2. That means if I took the square root of 25, which is 5, and raised that to the 3rd power, I would get 125, which is a true statement. All right, in Q, when the base of my exponential matches the base of my log, it simplifies to be 1, and I'm left with 12. All right, for R and S, that is going to be the one that I'm checking to see that you did, so I know that you have some understanding, that I know that you are doing the notes. At this point, please make sure you have answered R and S, that your name is at the top of these notes, and that you've turned it into the sub. You will now work on homework number 4 on Canvas.